All right, so I forgot to record this during class, so I'm just going to make a quick synopsis for people that were absent. And so what we're talking about in this particular unit is just polynomials, and poly actually generally means many. And so what happens is a polynomial function is a function that is defined by many pieces, and it's very loosely defined as many, because many in this case can be defined as little as one. Now, as we break this thing down, what you're going to find out is this is the way mathematicians choose to write this. The subscript that you'll notice right here, this little n, just means it goes with the term that has an exponent of n. And so notice here there's an exponent of 2 and there's a subscript of 2. And in math, anytime you have a subscript, it's like a name, like this one is Jill and Bob and Susie and Julio and Juanita, and you go down the line through all of these names, but the name matches the term that it goes with. And so if you were to have something like x to the fourth, you would have a sub 4 that would go with, in other words, a with a little 4 would go with x to the fourth. And as we go through this, those sub and superscripts, this is called standard form of the polynomial. And as you go through that, one of the things that we learned early in our course is we never wanted to divide by 0. And remember, negative exponents actually tell you to do reciprocals, which means you divide. Or if you have fractions, those were roots. And remember, roots created the possibility of taking roots of negatives. So you'll notice right here, n is the degree or order of the polynomial. And n has to be a whole number, like 0, 1, 2, 3, 4. Those are actually the counting numbers. So like, you literally say, well, how many apples are in the cart? There might be no apples, or there might be 3 apples, but it's literally counting numbers. And since you don't have any fractions, there's no roots. Since there's no negative, there's no division. And that's why we have all real numbers as our domain. So each one of those pieces is considered a term. And each of those little subscript is called an index, which is used to track them. Now those leading numbers, those a's that we talked about, could be any real number at all. So they could be negative, they could be positive, they could be fractions or imaginary numbers. I mean, not imaginaries, they could be irrationals, they could be anything we want. And the very last one is always weird to people, but remember I said the subscript goes with the exponent. So this is a sub 0, x to the 0. But since x is raised to the 0 power, it would be 1. So putting it all together, this is what a polynomial function would look like. Notice that I have 1, 2, 3, 4, 5, 6 terms. The leading coefficient right here is 3. The constant is -6. It's a 5th degree. And let's go a little bit further into this. And so we could look at this and say, well, which of these actually match that definition? Now, again, what we don't care about is what the coefficients, like the 4 or the ln of 3, look like. I care about the exponents, and I got an exponent of a 2, a 1, and a 0. And when I say exponents, I actually mean specifically exponents on the variable. So this is a polynomial just fine. This one is not, because there's an x in the exponent. And remember we said the exponents had to be whole number values, like 0, 1, 2, and 3. Letter C is definitely not a polynomial because we have an exponent of 2/3. I'm going to jump down to here. My exponents are a 3, a 1, a 2, and technically an x to the 0 here. So this one's fine. D is a bad guy because that would be technically 4x to the -2. This one is in a inappropriate form, but if you were to multiply it out, you'd get 2x to the 3rd minus 3x squared. That's 2x to the 3rd minus 3x squared, and so that one's fine. F is not going to happen because we got a fractional exponent. Remember, a square root is a half power. Over here, it's a little subtle, but since the domain of all polynomials, goodness, I hope that thing quits screaming. Okay. Anyway, since I'm dividing by x, and I know it looks a little subtle, but we can't divide by x, even though I could simplify and call that x squared, because technically right now, if I were dividing by 0, that would be a problem right here. And so this one actually does not have, this doesn't match the definition, so it's not a polynomial. Now, this is where I'm almost done, because polynomial functions always look like nice, smooth, and continuous curves like these two. These are definitely not polynomials. You can't have breaks in it. You can't have sharp spots in it. And the general pattern of these is these are kind of your classic polynomials that you're going to see. And so that kind of takes you through what a polynomial is. And then we're going to take a look at a little bit of the investigation on what I call 2.3a. All right, hopefully that's a good introduction to polynomials.